Hi everybody. Today I'm going to be taking a look at the IBM RS 6000 model 7006-41T. Now this is a very weird Unix workstation running an obscure and forgotten version of AIX, but there's a reason I'm showing it off in this video, and that's because not only is this a very weird machine with a forgotten version of AIX, but this machine could essentially be summed up as, what if IBM made a Unix workstation and didn't have anybody telling them what to do? And you could still see the same mindset with the IBM 6150, which was the PCRT, but this mindset applies to the RS 6000 and the early MCA series, because that's what this machine is. It's an MCA RS 6000 using the microchannel bus architecture, using MCA expansion slots, having no PCI or ISA whatsoever. And the best part is, this machine is very, very IBM. So here's the front panel of this RS 6000. There's a few things we can see right off the bat aside from our NASA asset tag, because this machine was ex-NASA. Here's what's cool about this machine. Aside from the PowerPC logo and the PowerPC 601 processor, this machine has nothing to do with later PowerPC RS 6000s or later PowerPC Macs, which were from around the same time, but they came out a little bit later. So let's pull the front panel off and see what makes this machine weird. So the front panel already has a lot of IBM elements to it, and it also has some elements that went away for the early prep machines and came back not long after because people complained, presumably, especially service people working on them, I guess. I bet you they would have. So this machine looks a lot like a 7020 40p or RS 6000 40p, but there's a big difference on the front. There's a reset switch, which is a rubber button that's big and yellow, and there's a 3-digit display, which displays what the process of booting is like, or postcode or whatever. It displays where in the process of booting the system's at. And this is very important because if AIX crashes, it displays the 888 code, and you have to push this to find out what the other codes are. So by getting rid of this and that, they essentially crippled the RS 6000 early prep machines. So they brought them back for the 140, the E20, the E30, and whatnot. Right here, we've also got our key switch, and I'll talk about that in a second. And then the power LED is right here instead of over there. So this system has a very similar LPX style case, but it uses MCA instead of PCI and ISA, or multiple channel as it's called in IBM documentation. So the documentation for repairing those later machines is called multiple bus systems, and these are called microchannel systems. So these MCA machines have a bunch of weird quirks, and the first one is inside the computer. The system has a socketed boot ROM, and if you have an MCA RS 6000, please dump that, because the thing is, that boot ROM is not only an EEPROM, but it also contains your system serial number. So even if you grab another RS 6000 boot ROM from the same exact machine, you're going to have a problem when you try booting it and you find out that your DRM'd node lock software does not like your new RS 6000 boot ROM. But even aside from that, you know, a lot of these boot ROMs aren't dumped, and if you're trying to repair one, you just can't find them. So dump your RS 6000 boot ROM, which is either on the motherboard or CPU board, depending on the age of the computer. So dump that. It's in a socket. You can't miss it. Take that ROM out, dump it, put it back in. It's free insurance. And you can use a TL866A2, or no, TL866-2, not A2. A TL866-2 will dump the ROM. So here's our front panel key. Now, on an RS 6000 of this era, it's a Medeco key. You know, the same company that Lockpicking Lawyer and others love to talk about, the same one that schools and government buildings use, the one that's mostly secure because of the do not duplicate mindset. So if you were to take this to a locksmith and say, hey, can I have a copy of this key? they're going to want you to show all this documentation to prove that you own the building or have the rights to make a copy of the key, because if you don't have the rights to make a copy of the key, they're not going to do it. And then they're also picky about who can make copies of the key as well. So not just any locksmith will do it. It has to be a Medeco locksmith, not your local hardware store on the corner. So this is a Medeco key. It's a 3-pin, not 5 or 6 or something like that. It's a 3-pin, less secure Medeco lock. And these were apparently used in filing cabinets as well. On other RS6000s, there's a 3-position switch, which seems to be a few of them. I don't know what the RS6000 SP used. The Pret machines did away with it. The Chert machines do it in software. And the Apple Network server has this key switch as well, even though it's not MCA for obvious reasons, and it's its weird own sort of hybrid of a PowerMac and an RS6000. So there's 3 key switch positions, okay? Locked or secure, and maintenance. Maintenance unlocks the case as well. It has a mechanism which locks this case out if you have it set to anything that's not maintenance or service or however you want to call it. So OK is standard, normal. It's the normal boot for the RS6000. When it's in this position, it boots AIX from the hard disk, or if it's a network system, it'll boot it from the network. This is secure mode, and it disables the reset switch and disables booting the system. Because if you have your key here and you try turning it on, you'll get 200 in the display, which is telling you turn it to here or here. And then we've got our service position. Now, how do you put a Unix system in single user mode when you don't have any sort of text or graphical user interface to tell the system, hey, boot in this? Here's how you do it. With a key switch set to service mode, because IBM. But seriously, you have to have the key switch set to here for single user mode to pop up. And the same goes with installing an operating system, because when it's in maintenance mode, it changes the boot order, so it boots from external SCSI CD drives and tape drives first before it looks for the hard drive, and then boots the Diagnostics and single user mode interface. And then when you have it here, it'll actually ask you if you want to boot into single user mode or do Diagnostics, which allows you to boot and test the system out and see what's wrong. And you can also put a Diagnostics CD in the CD drive, and it will do that as well. But that's the thing about these machines, is they are very IBM. So if you want to do that, you have to have it in the service mode. You can't just do it like type in a command and boot into this like you can on other Unix boxes. You have to have the key switch in service mode, because this system does not have a text user interface for booting up. It just has a basic fallback diagnostic tool if there's no boot devices. And the older ones didn't even have that, so it'll just loop trying to find a boot disk if you turn it on and there is no bootable device. Pretty interesting, but that's what IBM did. Now, one of the things IBM did with the RS6000 line is they also adopted a quirk that rival Unix workstation vendors, notably Sun, had in their Unix boxes, and that is a speaker in the keyboard. So Model M's usually have a grill for a speaker, where they could install a speaker if they wanted it. And Model M's also used the PS2 protocol for the most part, which had 2 pins that were labeled undefined, or not connected. Well, what did connect to them? The RS6000. The RS6000 connected a speaker to its keyboard. Now, this is an IBM keyboard, and so there's not a whole lot of differences from it and a normal PS2 keyboard. We've got our Control Act key here, which is the main difference. And we also have Alt being colored green on both sides. But what happens when we look at the back? Oh, well, we can see here our model number is 1394540, and we have a speaker here. That's right, this is a real speaker in a Model M, as you can see here from the lighting. And this is the beeper for the system. This is where all the beep sounds come out of. They don't come out of the computer, they come out of the speaker. Now, why would IBM do this, you might ask? Oh, and also this long PS2 cable. This long PS2 cable is why IBM would put a speaker in the Model M. It's simple. You were designed to basically place these keyboards in the monitor wherever you were having your workstation at, and then the computer could be buried in some cabinet somewhere. And the reason I say that is because here's a very real use case for these RS6000s that I know of. Somebody in a Discord server once joined and they posted a picture of their flight simulator setup. I think it was either for a CRJ 100 or 200 or a Fokker 100 or 50. I think it was the early CRJs though, if I recall correctly, like the CRJ 100 and 200. Those planes are still being flown in the air to this day. And you need to train on them because your FAA license requires that you train in a simulator for a specific plane type. So you have to find the building which still has the flight simulator for the plane. And guess what it's running on? It was running on two Silicon Graphics personal or professional Iris workstations, one of the two, but they were early SGIs. And then the other computer, I don't know if it was one or two, I might be mixing them up, but there was an RS6000 560 in the setup, which might have been, the computer to control everything. And the RS6000 560 and the SGI personal Iris were still chugging along to this day at a flight simulator. Really cool stuff. To think about how those old SGIs still, or old IBMs, are still in use to this day because they just work. And don't get me started on the PC98 still in use as factory computers with the FC9801 or the HP 9300s doing the same thing, or the VAC stations in use for semiconductor manufacturing. There are a lot of these types of systems still in use to these days that were installed in weird spots. And so a keyboard with a LAN PS2 cable and a speaker so you could hear the beeper anywhere made a whole lot of sense, because you got a monitor, a keyboard, and maybe a mouse there too, and not just a dumb terminal. And the dumb terminal had the speaker usually. But this, you had the keyboard who knows where, and so the speaker is in the keyboard. Eventually, when IBM made the prep machines and chirp machines to reduce cost and also to make the architecture more conventional so that others could freely build their own PowerPC machines, IBM went to using a beeper in the hardware itself and not in the keyboard, which is confusing because if you look at like the servers, you'll have to hear the from like a loud jet engine fan, and that's the only time you have to press the BIOS key. You gotta love some of these design decisions, but cost is what it came down to. Alright, so I'm deciding what the first boot of this machine is going to be for the video. I'm going to first turn it on in normal mode, because I want you to see what a normal RS6000 boot looks like. And this is also for a friend of mine who got an RS6000 Model 320, and I kind of want to show him how this thing works. So let's turn it on and see what it does. And I want you to notice something right here. Let's move the camera back a little. So right here is an important part of the machine. This 3-digit display. The 3-digit display displays what the machine is doing. It starts with 888 and then it starts into the 200 series codes. The 200 series codes are essentially when the boot ROM has control over the hardware. You're also going to notice that the LCD monitor is turned off this whole time. If this reminds you of the AS400s or some of the IBM mini computers, this was probably 100% intentional, because they have a very similar boot process. Well, it's more complex in an AS400 because you have all these settings you can set the system to boot in instead of just maintenance or normal. But the AS400 also is a system where it will not display console output until the operating system's loaded. So if there's something wrong with this machine, it will not display on the console. And when the system goes into the 800, 500, 900 series of boot codes, AIX is loading the kernel and booting. And when we get into the C32 displaying on the screen, which it still does on newer machines, then AIX is essentially loaded and it's now just loading the surfaces. And that's when the boot output switches to the console or monitor, depending on your system. So we're at 592 right now. 538, 581. And we got C32. It usually blacks out a little bit before displaying C32. And as you can see here, video output's on. And that's when this blacks out. And that's essentially what these front panel displays do on AIX systems. This display will not light up as long as the operating system is booting and running. And if there is a crash, it will display a distinct blinking 888 pattern. I have not seen that pattern on an RS6000 I have, or seen any way to trigger it from what I know. But if you see blinking 888 there, you would push this reset switch right here to decode what it wants to complain about. And that's what it would do on these older machines. On later machines, I don't know if it still does 888 in the operating system, but in the boot firmware, it will do something like what the AS400s will do. It'll shut down, you'll see the warning light on, and you'll see an 8-digit code telling you with a lot more detail what is exactly failed. And that's what the later machines do. Now, this RS6000 has a few differences from later RS6000s, mostly with AIX version 3 being able to run on here. Now, AIX version 3 is the other reason I wanted to make this video, because I want to show you an old version of AIX that's essentially the first version of AIX for RS6000s, and I want to show you the weird quirks of it. And right now you can see one off the bat, the font. Now, when you're loading AIX4 or booting into the boot firmware, it uses a sans serif font. This uses a Times New Roman style serif font, kind of like on the Sun workstations or the DEC station or some Japanese Unix machines such as the Omron Luna or the EWS 4800 from NEC, and of course NetBSD. Some of the BSDs love that font for some reason. I think NetBSD uses this font, but a bunch of the BSDs use this font for some reason. So let's open up SMIT first. Now, as you can see, SMIT has changed very little, except you can choose the top option and it doesn't do much. It's got the same AS400 style user interface, and you can choose what you want. You can install software, you can check communications, you can check NFS stuff, you can hook up NFS share if you want. We can do spooler print jobs. And as you can see, it's a very IBM style operating system because there are error codes for every little error message. And the same goes with utilities. On AIX, even to the newest version, there are error codes for every utility. So you could call up IBM and say, what does 1800109 mean? Or look in a manual for this error code. Because otherwise Unix didn't do that. But AIX does this. That is IBM's weird AIX feature. We've got our, let's look at devices real quick, because I want to list devices and all supported devices, and I want to show you something and explain why you have to have an MCA machine to run AIX 3.2.5. Well, there's two things you need. As you can see, everything here is MCA or some other bus, but there is no ISA, there is no PCI. The most is SIO. But there is no MCA and there's no there's MCA, there's no ISA, there's no PCI. And that's the first thing AIX 3.25 needs. But it also has one other major thing you have to know about, and that's the CPU. So this system I mentioned has a PowerPC 601 in it. And we're going to hit list devices, all defined. A CPU isn't shown, or the type isn't. But it's a PowerPC 601 processor. Now, if you don't know anything about PowerPC, you cannot run this operating system on a 604 because the PowerPC 601 and 604 are different. And how different are they? The PowerPC 604 is a clean PowerPC design. It's basically PowerPC by the book. The 601 is not. The 601 was sort of a transition CPU made to get people running power systems onto PowerPC. And how they accomplished this is the PowerPC 601 supports pretty much all of the power instruction set to my knowledge for the most part, along with quite a bit of the PowerPC instruction set. It supports basically a bit of both. So the PowerPC 601 processor will run stuff written for the power processor without needing any workarounds or any emulation, but to run PowerPC code, it needs a little bit of emulation. It needs a little bit of instructions basically translated over to the 601. So this led to some slowdown issues with like Mac OS. But on this platform, this would actually run Power 1 and 2 programs really fast compared to a 604, which in theory would have slowdowns. And I heard that at least on some earlier 604 operating systems and machines, it wouldn't even properly run right. Like old programs written for the Power 1 and 2 and compiled for that would need to be recompiled and all that just to run on these newer 604 machines. And there's also another problem I gotta show you when I'm done with OS level. This is not Y2K compatible. I gotta install the Y2K patches. But first we'll start X, because why not? So this is one of the things that I've wanted to show people with regards to AIX. This is the IXI desktop. This is not CDE. This is the AIX Windows desktop, also known as the IXI desktop. As we can see, it says IXI. So this desktop was made for essentially any Unix, and IBM was not the only licensee of it. Dell Unix featured IXI. Data General's DGUX featured IXI. At least one of SCO's operating systems featured IXI, and they wound up buying IXI in the end, when IXI was becoming less relevant because of CDE. Now, CDE came about, it was a much better desktop, in all honesty. It was this easy-to-use, full-on desktop that didn't require any sort of learning curve, while this, on the other hand, has some weird metaphors like a root desktop and a personal desktop and power desktop. Like what is that if you haven't really used this desktop before? But we've got our folders here. Some of them are familiar. There's some interesting icons. We've got a recycling icon for RM, a power plant for PS, a man and an icon for man, skull and a crossbones for kill, grep being a magnifying glass, because that's kind of what you did with it. Same with FTP. Dump being a literal dump truck. A literal cat being the cat icon. And we've also got our X programs, which are the typical X11 utilities. And also this has PEX, FIGS, and OpenGL, even though this GPU is only a 2D GPU. We've got some toolsheds folder. Who knows what that even is? And so we've got ourselves, this is a root file system. It's not a root desktop, but there's a root desktop somewhere. We've got samples, which are samples of animated icons that IXI could do. And there's some sample programs too. XIs does not exist on the system for some reason. And we've got a tree view icon too. So let's get out of here. I'm trying to figure out how to use this desktop. I'm really not too much of a fan of it. Where's root desktop at? And we've also got some C programming stuff here. We've got make, CC, and you have to drop stuff onto it. No. We've got some applications here. I don't think they are on here. And so basically these are licensed. You have to pay money for these from IBM. And then I don't think anybody's dumped the CDs they're on either, which is a shame. There's a lot of undumped AIX CDs out there. Imagine what could be on them. I mean, somebody recently dumped AIX for Itanium, the version that kicked off the whole SCO IBM lawsuit, but nobody has a machine that can use it, unfortunately. So, I gotta find out where the desktop is. There was a root desktop somewhere. And I can't find it. I gotta find out where it is. Admin, here we go. We've got some of these at least. We've got set desktop. That would create the desktop files or something. And we've got SMIT. The same exact editor that was used on later versions of AIX. And in some ways it has not changed. Let's go and set up devices or networking communications. Let's add a file system. Let's hit do. Okay, actually, let's do this first. Running man icon, same thing, hasn't changed. The famous running man icon that will fall if it doesn't complete is still there. You gotta love that, don't you? So let's do something else here real quick. Trying to find out what else I can do real quick. Let's go to network communications, TCP/IP. Let's list all services. See, the same thing does that. So let's back out of here real quick. And I gotta show you another cool thing about old AIX. Alright, so here's something really cool that exists on old AIX and still works to this day. Fixdist. Now, fixdist is this essentially AIX version 3 or version 4 software download tool, and apparently they've phased it out for, I guess you could say, downloading it straight from IBM's Fix Delivery Center, which they've probably renamed to something like Fix Central. And so what I'm going to do is I'm going to hit apply save. We're going to have to refresh the database. And it's currently downloading this stuff from IBM's FTP. Because this stuff is still up there, believe it or not. Now, unfortunately, patching AIX is still a royal pain, if you know what I mean. It's throwing up an error message probably because my clock's all messed up because of Y2K. But now we can get updates and download specific fixes. And it takes a while to load because there's a whole lot of updates for AIX 3.1.5 or 3.2.5, but also probably some for 3.1 even. We're going to search next. And we can find some Y2K updates here. We're going to download this. And I'm just going to choose 3.5.2.0 because that's our AIX level. And it's telling me that it's been superseded. And it's telling me what I want to download. And it's going to show me what it wants me to download. Let's go back here and download. Let's download this too. It's going to download a bunch of stuff. And it's going to take a while because unfortunately I'm hooked into a remote NFS server while downloading a file on a 10 megabit connection with one of those AUI dongles. So this is going to take quite a bit of time, but if I look back and look at the light blinking, it's definitely doing some stuff. Alright, and that took a while. So you can see there's a lot of patches that exist I can search through. So I can search year. And there's some year 2000 updates too. Let's go back to year. And I can get all these patches here, find out what's there. You could even email it to a certain address, like if I wanted to send to like some account that I was doing this administrative task, I could do that just by clicking the email button, because you have to remember this was the 90s. This was the 90s, and so Unix had email from the get-go. You know, that's the thing that's really cool about these old Unix workstations, is that there were a lot of cool features with these systems in general. I really liked them. Alright, so I've installed some, well, I've downloaded some year 2000 patches. So let's generate the table of contents. So what you would do is you would open up a folder and you would type INUTOC to do this. And it hasn't changed with the newer versions of AIX either, which is pretty cool. The thing with AIX that really makes it a good operating system, and one that is as long-lived as it is AIX is notable for not changing too much, and also having backwards compatibility. So not only in theory could you purchase a brand new IBM Power server and run older versions of the software, or depending on the hardware or virtual machine, even older versions of AIX, but you can also, you know, maintain it the same exact way you would newer versions or older versions of the operating system, which is pretty great because it makes it easier to do maintenance and all that. And SMIT is the same way too, hasn't changed too much. So we're going to go and do this, install selected fixes. We're going to push dot, we're going to push list. I'm going to hit dot and I'm going to hit do, and we're going to hit list. And I didn't change the directory. I got to go to so we got to change here, and we're just going to do dot there. You don't hit list, you hit do, and then you hit list. And we've got our fixes here, so we're just going to let it do all. Commit set to no, that's good. And now we've got our running man and AIX is installing patches. And also about reliability, the same goes with the hardware that this operating system runs on. Because these RS6000s are very, very reliable machines. They just work. Like, they really just work. They just keep on going even when, you know, all the stuff seems to just not work. They just keep working. And that is why these RS6000s, you know, have high resale value, because if they break, well, especially the older ones which are out of support, somebody's going to want to get parts for them. So they'll go on eBay and look for parts, or they'll go to a reseller who specializes in these RS6000s, and they will get parts for them. And that's what's really cool about these RS6000s. They just last, and they just keep running. And the same goes with a lot of computers are out there. And as we can see, some of the stuff found stuff that wasn't installed or not applicable, but other stuff has been found that is an update. And unfortunately, we got some error message, so the running man failed. And I'm gonna have to increase the temp size to install these updates. So as you can see, some of these, you know, these updates don't apply, other ones do. And that's pretty much how AIX updating looks like. Sounds about right. AIX patching can be a pain sometimes, but I'm going to have to increase the temp size before I can install patches. But I think you get the gist of it here. We're going to end session. And I'm going to shut this thing down real quick. So there you have it. An RS6000, a lot more reliable than some Discord server or Discord server admin or internet friends. This is a lot more reliable than those are because it's an RS6000. Alright, so the shutdown is complete and the text says halt completed. So what I'm going to do is, it was in here, I'm going to turn it to maintenance mode and show you what the service mode on an RS6000 looks like when you try doing a service or maintenance boot. Let's push the reset button. Oh, and it's not resetting, it's actually doing the whole, it's actually taking a dump. So the thing with these RS6000s is, this button in AIX doesn't always act as a reset button. It acts as a dump button. So even if I push this again, it's going to go to 0C2, then 0C0, instead of actually resetting the system. So I got to wait for this to hurry up. And you're already learning another weird quirk about the RS6000s. The reset button is not really a reset button, but rather it depends on what it's doing. So we have to turn the system off and then turn it back on. So it's doing the same things that it was earlier, but it's going to do a little bit more tests from what I can tell. There's no disk in here that's operating system related. .219. It's doing the RAM test. So now it's blinking the hard disk because it's loading the operating system. Or at least trying to. It's trying to see what's on there. And it stays at 253 and 291 a bit longer because it tries to go through different devices before it gets to the hard disk. Now we've got our 500 and 800 codes because AIX is coming up. And you'll notice that the operating system doesn't come up. Instead, we get kicked to a diagnostic prompt. So we're at 828, 821, 8 something. And there we go. We're getting real close to our boot screen because the monitor went into power save. C32. And it's doing some diagnostics on the display adapter, it seems. And here we are, the diagnostic menu. So as we can see, we've got our diagnostic operating instructions. And we can do a few things here. Now, on later versions of AIX, you get the single user mode. But on this version, you get diagnostic routines, advanced diagnostic routines, service aids. And there's a few things here, including service hints. And this is the README for this. And we've got ourselves a few other things we can mess with. I think AIX shell is the closest that you get to single user mode on this. And so I'm going to type W and where you're currently logged in, and we're currently at the main menu or root partition. And if we type exit, we'll get a few other options. Sorry about that noise, that's my laser printer throwing a tantrum. So we've got a bunch of stuff here that we can mess with, including SCSI bus, for example. But we're going to back out and we're going to choose diagnostic routines. System verification. And we're just going to choose one of the more interesting tests on these machines, the GXT150L. Now, if you've ever done an AIX graphical hardware test, you actually get a few pretty cool test patterns flashing on the screen. And the video camera doesn't exactly capture it, and it really depends on the card. But kind of like how on AIX you get these cool test patterns. And so it depends on the GPU. Some of them for the AIX systems have some cool test patterns. Let's go to base system. And then we've also got a few like base system tests I can run to make sure that the motherboard works. There's also a test which displays 666 and 999 on the front panel to make sure that all the digits work. There's even a key mode switch, which lets you turn it to all three to make sure that the switch works. Let's hit cancel. Let's cancel. And we're going to shut it down. Now, in later versions of AIX, they've actually given you a single user mode option with the key switch, but this is AIX version 3.2.5, and so a lot of stuff still isn't here yet. But you can already see the basis for the later versions of AIX, if you know what I mean. So there we have it. Pretty cool system, pretty interesting version of AIX that's pretty much long since forgotten about. And that's all that needs to be said. Personally, I'd probably try to run 4.1, but I've already got an AIX box that can run 4.1. I've got one that can run 4.3, and this is just, it doesn't even have a sound card, where my other AIX box can run 4.1 with a sound card and PCI. So there you have it. Thanks for watching and subscribe for more.